Hello, good day, everybody. Welcome to this month's Rust Gamedev Meetup, where we can talk about the kind of cool products we've been working on, some of the nifty stuff that's been going on in the ecosystem, and hear from also some other people on what's going on. So I'm super excited for this month. We have some pretty cool stuff going on. Now, I also want to mention we don't have this, or I guess last month's newsletter posted just yet. And so for anybody who's interested in getting your project or game or library or educational material into this edition, feel free to make a pull request. We always have, actually, let's just see if I can get to there quickly. So we have like our link to the working group. And then inside of here, we have a tracking issue on this month's newsletter. And so lots of awesome stuff going on in here, everybody contributing in their sections. And so if you have something cool to show off, feel free to do that. Now, before we get started with everybody else, I do want to show off one of the projects that my friend made. And actually, I didn't know he was working on this. I posted this on the Rust subreddit, so you might have seen it there. But my friend, he made this like minimalist microcomputer he calls 808. And the reason I wanted to show it off in the Gamedev Meetup is because he added control inputs to it and then coded Flappy Bird for it. Now, I still have to go through some of the code of how this works because the product itself is written in Rust, but then all of the games that you write are like in this version of assembly for like the stack-based language. And so I'm super curious about how he went about getting Flappy Bird set up. And just to specify, all of the instructions for the games or for any of this to run is in this section of RAM. Like this is all of the RAM you get. And so this has to be your code section up top. So that's the stuff that's not changing. And then the stuff at the bottom is like stack and heap. I don't know if you'd have a heap in this case. I guess maybe it's all stack. But anyways, I want to dive into this because to me, it's super cool that you can have something encoded in this little amount of space, which I think is 256 bytes. Anyways, that's just one of the awesome things that we have on the plate for today. Hopefully, I'll write something about this for the newsletter. And so if you want to check it out later, you can do that. Now, we have three presenters today. We'll be hearing from Elham about Blue Engine. We'll be hearing from Wumpf about Rerun. We'll be hearing from Kevin about Graphite. So without further ado, we will be back in just a second with Blue Engine. All right, Elham. So yeah, it's been a few months since we've heard about Blue Engine. So can you tell us what has been going on since, or actually, you want to start with Rusty Engine first? Or sorry, Rusty Game Jam. Yeah. Okay, awesome. So Elham is one of the leads of the Rusty Game Jam. We were talking about showing off what's coming up with that. So Elham, I'll let you take away with the Rusty Jam 3.
Thank you very much. Hello, everybody. I'm Elham. One of the co-hosts of Rusty Jam. We do Rust Gamedev Game Jam every year, and this year's is going to start in a week. So this year's, as always, we won't be disclosing the theme and the extra details before the jam starting. So if you want to participate, we'll send the links on the Discord, and will be available around on YouTube too. But basically, it is working groups, Rust Gamedev working groups, official game dev, co-hosted by me, Angel, Energelis, and Oscriff. We had 2 game jams before. This is our 3rd entry. And I'm very excited about how it will lead. So the way it works is right now you can join the servers and look for teams and build up like your plannings and your works and your timeline for it. It will start next week, and then we'll have the jam for another week or 2. And after that, the submissions will be closed. The submissions are open from the start of the game jam week. So you can apply it anywhere. So you can submit your games anytime. And after the submissions ends, we'll have another week where you'll be rating the games that have been submitted. And the winner will be announced at the end of the rating week. So that's the timeline of the jam. We'll also be posting about those on the Game Jam server. But yeah, that's basically how the timeline works for that. So from right now up to next week, you have time to make teams and plan your timing for the Game Jam. And the only catch is you can use Rust programming language, so you're not restrained to any specific game engine or ecosystem. So as long as your game is written in Rust, you're free to build anything and submit any game. But yeah, that's about Rusty Jam the third.
And now, one thing I want to mention as well is last Rusty Jam, the theme was cat dog, right? I think that, like, I'm
Yeah,
just checking out the, yeah. So I'm very interested about what this the theme is this time. So last time, 17 entries is super cool. I love seeing all of these entries that just have a different version of like the cat dog in their image, and so yeah, super cool to see what people will come up with this time around.
we had a lot of cool entries, to be honest. Even on the first jam, there have been 3D, 2D, and even web-based games, even on Edge. I think you can still play some of them on Edge.io, but it was really cool. I'm excited what this year has for us.
For sure, for sure. And then, yeah, with that being said, I'll introduce, well, I guess Blue Engine again. So I'm super excited to see what upgrades have been happening. And also, I want, well, I mean, as you're going through, if you can answer the question, do you think Blue Engine's in a place that you can see some entries into the Rusty Jam with Blue Engine? So yeah, I'll let you take it away.
Thank you very much. For those who do not know, Blue Engine is a graphics engine mainly, and the way it works is it doesn't give extra detail, extra functions and functionality for you besides just the graphics part. So it's mainly just graphics. You don't have audio and audio networking and stuff like that. So it has graphics, you input, and anything related to that. But there are utility crates since last year, so the extra functionality that are needed are added to the utilities crates. So that could make an entry to the games. And we also have this month's very special addition that could actually make it useful for a video game, especially 2D. I think that's the main that can be done right now. Um, because this month we have physics. I've been working on physics since a couple of months, and this month it's now usable. We're using Rapier physics right now, so I'm implementing Rapier 3D. And aside from Rapier or normal physics, I'm also planning on adding raycasters and anything related to the 3D, which also aids on the editor development, because we also have an editor for those who do not know. And I can like show you a demo of Rapier working, and this it would look something like this. We have our normal physics, we have bouncing collisions and everything added to the engine with just normal objects. And for those who might wonder how the difficulty of using Rapier would be, it's just as simple as it can be. Most of the boilerplates are hidden behind, but it's also like exposed, so you can do it yourself or make additions or configuration as you like. So it's not holding your hand too much, but it's also not restraining you. So the way it works, for example, on the example we have a normal floor for the engine, which is a cube, and just simply you just add a collider for it, and that's it for the rapier. For the balls, it's the same thing, just adding collider and rigid body for them so that gravity works. There's two balls here, but yeah, that's about it. You add the physics plugin, and you can just update the physics or however additional details that you have here. I am working on the ray tracing or ray casting side of it, so I'm not gonna explain this side of code because most of it are not really gonna be used right now because it's very experimental. But aside for that, this has been the physics is the main updates that has been done this month, and also I've been working on the models, model loading, and uh, I can't really show any graphics for it, but I'm really planning to get a full render of Ferris 3D model. This model, for those who don't know, it was posted on Rust Gamedev's art channel, and it was basically a way to render for Rust models or examples in 3D engines. So it has Blender files, and you can also 3D print or anything you want for it. It is really cool. You should check it out. It's by Raymark, and yeah, I'm planning to make it work on the Blue Engine, but if it does work, we'll be posting updates on it. And yeah, model loading and physics was the main things that was happening last month, and is going on still in this month. But yeah, that's all the updates I have from Blue Engine for now. For those who want more updates and like questions or more. Oh yeah, I also forgot Iced. I've been really interested in Iced GUI and recently, so I've been trying to add it on the Blue Engine. A lot of progress has been done, but I am stuck on one part of it, which is a trait problem. It needs a specific traits, which I was really confused on. So if anyone have done or implemented Iced on their engine, or have used to add it on like their own pipelines, I would really appreciate if you DM or contact me, because I've been really stuck on it for weeks. The rest is working. I've updated both Iced side and my side to the latest WGPU versions. So I don't think it's a problem of versions. I'm really confused on it. But yeah, those are the three things: Iced, model loading, and physics for this month on the updates. And on the question of it, if it can be used for making games, I'm not really sure it can. It can be for those who want a challenge. So I'm not really sure yet. It can be used, but it will be a lot of work to make it work, like make a game with it, especially right now, given that a lot of things are experimental. But yeah, that's about it from me.
All right, super cool. And so, I think a few things that I want to mention here. So, having sort of written a game engine slash framework that was designed to just do Pong, and then have it be used for a game jam at Rust Nation, what I found was like the day before, we're like, oh my gosh, there's so much wrong with this. It's like terrible. You don't have anything implemented, all this kind of stuff. But then the stuff that people made was amazing. It blew my mind. And so I think what I learned from that is like, put enough together and then give people a help when they get stuck. But then what actually happens is that like one person actually went in and contributed the ability to render fonts into like the into the screen. And so for us, we're like, oh my gosh, we didn't know how to do that. So that's awesome that you're able to put that together. And so, I mean, if someone wants to give it a go, like kind of it's like dog food it, see what happens, give them the ability to come back and chat with you about what worked, what didn't work. But so that's one side. And then the other side, I think, is that games come in a lot of different forms. And if someone's able to just like make a toy, make something that you press a button and it moves around, it does some physics and kind of sees what's ergonomic, what's not, I think that's super valid as well. And so, yeah, I think it'd be awesome to see some Blue Engine stuff.
Oh yeah, absolutely. I'm really excited, but if anyone wants a challenge, I'm on the Discord. Come on anytime. I will be available to assist you on any part that you would need. But yeah, thank you very much for the speaking this month. I'm really excited for what we'll have in the next month or so.
Absolutely awesome. Yeah, I'm definitely excited to have you back. Now, one question we did have in chat regarding the Rusty Jam that I just want to bring up. So there was a question, any thoughts about any policies on using ML generated content? And so what we'll do is we'll take a look at that. We'll come up with something that we do put on like the Rusty Jam intro, just so that we're not exactly sure what we'll say just yet, but there will be something that does specify that. So I just want to make that clear. So yes, anyways, Elham, thank you so much for showing stuff off, and hope to see you in a future month.
Just as well. See ya.
All right, so next up, we are back here with Wump, who's going to be talking to us about Rerun. So Wump, I'll pass it over to you.
Yeah, thank you so much, Forrest. And yeah, again, also thanks for reaching out and having me here on the show, so to speak. Right, so let's talk about rerun. So rerun is a visualization tool by the company with the same name, of which I'm happen to be an engineer of. So this is very much in own interest, very biased talk. And yeah, I want to show what rerun is and shine a bit of light on it, how I think it could actually be useful for game dev. So yeah, I guess that's also right where I start. Like rerun primary focus today is to write a visualization SDK for computer vision. But the tool is fairly generous, fairly versatile, and I think there's a lot left on the table where it's still useful. So the SDK itself, you use it today from Rust and Python. At some point, we're also going to have C, but obviously we're all just interested in Rust here. And yeah, on the right, you see a bunch of screenshots like of fairly complex use cases. Most use cases aren't that complex. So on the top, we have like a reconstruction where like a mesh reconstruction where somebody like walks with a camera through a room. And in the bottom, that's actually a visualization of the like the different steps of the stable diffusion image generator. So yeah, it's like a fairly heavy lifting going on there. But in essence, it's just visualization, right? Like think of it as like plotting on steroids. And yeah, our tech stack, like it's Rust, otherwise I wouldn't be talking here. And like all our UI is done in eGUI. So it happens that our CTO is the main author of eGUI, so that was an easy choice. WGPU is our renderer. It's a custom in-house renderer based on WGPU, and our database backend, or like sort of all the data that users log, they end up in the arrow format. And yeah, it's worth noting, like, I mean, we're just another open source library, and as one, we're also trying to be well behaved and contributing to all of these libraries as we go. So you will find us on all of these popping up quite a bit. Right. So let's dive into a bit more. Like when I say like visualization, like what do you visualize there? And yeah, we're just starting, but when I like went over the list, I was like, oh, right, we actually already have like a ton of stuff that you can log, right? So that's usually how it goes. Like in your code, in your Rust code, you would go like, hey, log these things. I want to show this. And then you would like, yeah, log points, lines, tensors, or even also meshes, right? So it's like interesting if you have like mesh reconstruction or things. And the nice thing is you log them over time. So, and you can have this on different timelines. So that's like really a thing where rerun shines today. Like you can record arbitrary amount of data and then like go back and forth and analyze what happened. And yeah, as a lot of people in Gamedev are familiar with, the whole thing is an entity component system. So yeah, I should have added like my background is actually also in game engines. That's what I did before joining this startup. All right, and yeah, what do you use it for? I put it here on the slide. I already mentioned a few of these things. So it's really about like understanding, and we figured like especially in computer vision and robotics and that kind of like really complex scenarios, there's a lot of lacking, right? Like a lot of people just like log these things in matplotlib and then like, try to like put all these windows together and somehow, and we're like, yeah, once you have more complex stuff, like more data over time, more complex data, it's really hard to like find good tools. You're often very much busy building your own. And on top of that, it's also a pretty good debugging tool, because I said like you can go very easily go back and forth in time. And it's very nice to like zoom in on like, hey, what actually happened. And since you can save these recordings, you can also use that for like, yeah, accumulating your data over time, and then like at some point figure out like, okay, what actually happened here, or like build up a database. And of course, we're trying to like, be good looking, so it's also nice for demonstrating. Okay, so far so good, but I mean, this is the Gamedev Meetup, so like, why the heck am I talking here? And I should have thought of this. The top right is a video that doesn't work in this fly share. Yeah, I can show that later when I do demo. So yeah, to our surprise at the company, like actually people are already using rerun for quite a bit of Gamedev. Like we're only a couple months that we released our open source, and we're already seeing like a lot of cool stuff. So the thing that we can't see right here, that you would have been seeing like a skeleton from an Oculus. It's interacting with different things, and so somebody like recorded the skeleton in there to like see like, okay, what is the camera, like what is the system actually doing there? And the small something on the left here, like somebody did surface reconstruction for their fluid sim, which like, oh right, yeah, we've seen those like a lot. And my absolute favorite, bottom right, is a play session analysis of a StarCraft 2 match, which like, yeah, sure, right? Like in a lot of games, you have like very complex things going on during a session, and there's like two aspects of it, right? Like there's the actual development aspect of like, okay, did this thing do the right thing? And the other is like, oh, okay, what did the game players actually do? Like, how did the stats evolve over time? And on this one, on the little screenshot there, you see like all the unit movements. That example is actually fairly complex. I recommend you to like check out the YouTube video later, where like the SepOps, like he graphs all the like different properties of the game over time, and they can like really dive into like, okay, what did the players actually do? And I figure that's also like super interesting, like for like analyzing like what's going on in your play session. Right, yeah, let's go into a demo. First, if you could enable my screen share. Perfect. Oh yeah, I love these screens. Never gets old. Right, yeah, let's go right into it. So I prepared a little something here. We're gonna go. I'll just start. Let's start rerun itself. So what we're seeing now is the rerun viewer. It's waiting for data on some local port, on a network port. So yeah, let's give it some data. And for that, I instrumented a game I did last Christmas. The game itself is done in Bevy. It's a very, very simple game. It's basically asteroids, but since it's Christmas, you're not like a space trip. You're the Grinch, and you're not fighting against asteroids. You're fighting against presents. And oh yeah, there was Santa flying by giving more presents. Oh, and I lost a life. So yeah, you get it. It's it won't get more simple than that actually. But yeah, I did that for like an advent calendar. It was a lot of fun diving deeper into Bevy there with that. Right. So, but in the background, this game was busy logging data to rerun. So let's pause this here. So now we're actually seeing stuff here in rerun. Let's rearrange this a little bit. Right. So yeah, let me first give an overview of like how the software is built up. So at the bottom, we have our timeline. So I paused it, but by default, it would just catch up with whatever is latest. And I can go back in time here, right? So there's already like, as I mentioned, like one of the nice use cases here. I can just go back in time and see what was going on. On the left, I have like an overview of what I'm seeing. Right now, this is looks pretty much like a scene graph, as you can tell, right? You have like all of my different entities in here. But in the future, we're actually going to make this more of a representation of what you see. So like this blueprint is really all about like configuring what you're seeing in the visualization. Because like really, right now is a lot about logging data, but already in the second, right, I don't think I made it for the next release, but soon we're also like allow you from like edit the viewer here itself from your own code. Right, and then in the middle we have our space views. So I have 3 space views. I'll talk about that more. And on the right, you can also select things here. Right, so what did I log from my data? So first I have a plot here. That's the score over time. And we see we're not doing all that well. So the game is very simple. Like it just counts your score down, and every time you like hit something, it goes up. So a nice thing is I can now also like correlate this, right? So this is a time plot. I can go like so. All right, that was, let's reset this. There was a shortcut to move this around. I keep forgetting. Right. Whatever. Let's do it here, right? So I can see like, okay, why did I get? Here something got hit there, right? That's why the score spiked up again. And on the left, I have log messages. Like I kept it very simple. I just like logged all the times one of my gifteroids and one of my asteroids broke. And the most interesting one in view here is, of course, that one here. And I logged the collision geometry, actually, right? So, I mean, for this game, this is fairly redundant, right? I mean, you can see that's pretty much the same thing again, but you could imagine, like, using this as a physics debugger. Yeah, for this game, it's not that amazing. But still, actually, when I was trying this out, I found something interesting. So let's first make the point size a little bigger. So we see all right, here's the snowballs, I call them, like our little project house. So we zoom in on this here. So what actually happens when I hit one? So now I can go frame by frame even and see like how my objects are moving. And let's see. Now we should get a hit. Oh, okay, we got a hit. That's interesting. It disappeared. Oh, right, that was a small one. I actually wanted to see a big one. But yeah, that was an interesting thing here, right? So we got a hit. And so the object disappeared. Then we got a new snowball. And down here, something weird happened. That's also interesting. I haven't seen that before. So yeah, for that kind of debugging, it can be quite useful. So in this game, this didn't matter all that much, of course. But you could imagine like what I just showed, maybe that could lead to a bug where like a single projectile can destroy several objects, which I don't want. And yeah, one thing I mentioned in an earlier slide is that I can log custom components. So if we like select one of these guys, oh, I forgot to zoom in. Zoom in here a little bit, right? Right. So now we can see like, so all of these little presents, I logged them as line strips, but I also added like an extension component, you know, said like, oh, right, so actually this one has size 1. And if we go over here, right, that one is size 2. And that one is also size 2, and that one is size 0. Right, so we can really look at arbitrary data in here. And of course, this is a very simple toy example, but it was easy enough to put together. So yeah, let's add proof to that and show some code. So this is how my baby game starts essentially. I must add, our Rust API is not amazing yet. I'm using a build from our main branch because it got a little bit better there. But since I said, like, due to our computer vision focus, a lot of stuff is happening in Python. But we're getting there. I mean, the software is in Rust itself. It would be a shame if we wouldn't have a nice Rust API. So what I'm doing here, essentially, I'm connecting to a rerun viewer on the default port. So the port is what rerun showed me on startup. I have it local. It could be a different machine. And I made like one addition here. I wanted to send with a higher frequency than default, so I have it nice and smooth. So it shouldn't buffer up too many messages, which it will do by default. And then I set this recording stream to the global recording stream so I can use it later. And the whole thing is feature gated, right? Because yeah, when I ship my game, I probably don't want this. And then I run my game as normal. And then later, I just add, like here, I have added a system to whenever like my gift or oh no, sorry, that's actually not a system. Let's look at this one. This one is a where did I put this? Oh yeah, here, right? Here I added a Bevy system. If you're familiar with Bevy, like I get all these queries I do over entities and over my entities and specify which components I want. And then I just go through them again and log all these lines. So yeah, here's like a sort of a few to-dos. Like rerun right now doesn't have like rotated rectangles. It's only like axis-aligned rectangles. So I used line strips for these little rectangles, and then I send them off to rerun. And I specify a time, and I actually also a timeline, and the components that are just defined. And I could add more components, right? So for example, for my Grinch, the little triangle, I actually also added a color, so it like sticks out better and doesn't use the default colors. Right. Yeah, I think we can go back to the slides. Thank you. Yeah, that's it already. I'll leave you here with a bunch of links. So in Rust, it's fairly straightforward. You just add rerun and like the next version, ideally 06 next week. We're releasing about like every 2 or 3 weeks, trying to keep a high cadence right now because like we're still adding a lot of stuff. And in Python, it's even easier. You could just go pip install, and it's rerun SDK, not rerun. That name was sadly already taken. And yeah, you can find more about the website and our docs. There's also like a getting started example for both Python and Rust. And you find us on Discord. We're always way happy about anyone like showing off what they got or asking questions or complaining how shit everything is. Because I assure you, there's still a lot of rough edges, but we're getting there. And again, a link to my favorite example for like play session analysis, the swarming example, and what I just showed you, the Asteroid example. And yeah, that's it for me already. Thank you.
Awesome. So we do have a few questions here in chat. Can I bring up your editor screen just so we can take a look at the UI again?
Yo, sure. Go ahead.
Perfect. Awesome. So first of all, when I saw this, I'm like, wow, there's like a lot put together. I've been playing with eGUI a little bit for my own stuff, and definitely a nice system to interact with. So one point that was brought up that I heavily agree with. Rerun looks like it might just be the thing to diagnose by physics bugs, and I love that so much because now correct me if I'm wrong, but when we see like this sort of view in the bottom right, this is like image processing that's happening on the screen to denote where objects are. It's not the it's not like interacting to know where stuff is in memory, right?
Not sure if I got that question right. I'll try to answer anyway.
Yeah, for sure.
I mean, what you see here on screen is data that was sent over to rerun, right? So like this data is in a way independent of the game, right? Like the game bundled up the messages, sent it over to rerun, and then rerun can like look at that data, right? It's like I can even dive in here. It's like, oh, okay, so actually you sent me a bunch of positions. Was there another way to look at these even? There was a way to look. Maybe that's a new bug. Right, yeah, but I mean, you can really like just look at the raw data that you sent, right? I mean, in the end, that's what it is.
Okay, super cool, super cool. And so, I mean, as just a UI to kind of see stuff moving together. So when I was doing some amount of image processing in university and kind of playing around with this, but when you can look at stuff in this form, it seems to me like you could do a lot of testing on top of this to see, does stuff happen properly? And so to Kevin's point about being able to use this for like diagnosing issues, like do you see this being part of a test framework where you can like either write some types of tests or analysis or something on top of the system?
Not yet, but I think it's definitely it's an interesting idea. I mean, the nice thing is like the database that we build up by gathering all the data, you can save that out, right? Like I could save this out now, right? The file format is not stable yet, but you could imagine that like, yeah, you put this on a server and then you process that after the fact, right? Like, so you use this as pure recordings. So I mean, also the nice thing is like the game. I probably should stop that, otherwise it keeps on spamming rerun. Right? I mean, the game doesn't know about this application, right? Like,
yeah, exactly.
I compiled this without like I could build in the viewer actually into the game. I mean, it's just another Rust application. But yeah, I mean, really, just at that point, just like a communication format that the viewer then can look at. So yes, but I think the main thing we're lacking so far is UI elements inside the viewer. That's definitely a thing that will come, so that you like add your own buttons and they get the callback. And then I imagine you could also do like, okay, I looked at one thing and now I press like an analysis button directly.
Yeah, exactly.
So, yeah.
And I think your point about this data being separate from the context that it's in is really cool, where like in a lot of ways when we're doing, well, from my experience when I've done stuff like flame graphs and all of this, it's all about like recording how long something is and not any of the context of what's happening in there, but just getting telemetry about it. And so this is like more of a maybe visual way of analyzing that telemetry.
Right, yeah.
Okay. And so I mean, definitely like, so this case right here is looking at a video game, but I can see like a lot of applications for like robotics and similar like real life to data pipeline kinds of things, which is super exciting.
That's good to hear, because I mean, I'm super excited about like people trying this out for all sort of things. But yeah, as you say, right, like the main focus is like these really complex ones. Is this still running? I haven't tried this in a while. I mean, I can also show this live since you. Oh yeah, right. So this is similar from the screenshot. It's a bit fake because this one already has the mesh reconstructed. Like in the original, the mesh reconstructs on the go. But yeah, right. And I mean, you have these way more complex pipelines where like, oh, this thing is looking at that, and then there's like a def image here, and yeah,
well,
you want to like figure out what's going on here.
So, like this is the thing that I've seen with rerun before, and there's a lot going on here. So can you walk through a little bit about what's going on with these different views?
Okay, yeah, I can. Let me try at least. Let me try.
Yeah, for sure.
Right. So yeah, generally again, like we have on the left, you can see like all the things that were logged and actually also what we're looking at. Right. So and yeah, this one is a bit messy, I admit, right? Like because like we're still lacking a feature that you can like look inside this mesh. It's almost a bit embarrassing at this point. Like,
I don't know about that. I like when I saw this, I'm like, wow, this is super complete. Like sure, there's some stuff going on, but at the same time, like when I've done either visual effects or anything, and I was talking to you about this before we started today, but like when I was playing around with this, like these ideas, a lot of it was like you have your camera and then you move it around the world and then you just track it, but there was like no chance of like actually making a 3D object just from footage. And so yeah, like seeing this, I'm like, wow, this is pretty cool.
Right. I guess that's the thing I should also clarify for everyone in the audience, right? Like rerun will not do the computation here for you, right? Like somebody developed an algorithm that reconstructed this mesh, and they were like, am I doing the right thing?
Yeah.
That's a surprisingly hard question, right? Because you spend all your time like doing this mesh reconstruction, all these things, and now you also need to read up on rendering. It's like, well, great.
Yeah.
It's like, which that's kind of unfair, right? Like, or like, oh, I wanted to plot this. Like, oh, come on, do I need to write a plotting library now? It's like nobody would do that.
Okay, so this sits more on the side of you have the data already, and there are different ways of visualizing it within rerun.
Precisely. Yeah.
Okay.
Yeah, so I mean that's a common misunderstanding, right? We have all these like flashy use cases here, and like but like this is really a visualization tool. Right? As I said, think of it as a plotter on steroids.
Okay, and I mean even looking at it like that, these two separate views where you can hover over one side and it like kind of raycasts into the other, and then you get a lot of data about what depth and what color and stuff like that. Like I mean that still has an insane amount of applications if you can. I suppose like build your own modules, like if you want to do stuff for like medical, if you want to do stuff for robotics, if you want to do stuff for game dev. Yeah. And actually just out of curiosity, what does it look like to add another module here that displays information differently?
Like you mean like a new view that works completely differently, essentially?
Yeah, exactly.
Right. I mean, so the UI allows you to like add, I mean, what I just like did casually here, right? Like I can just add more stuff here and then they pop up here, right? Because I mean, as I said before, this is really a representation of what you're looking at, not so much what is logged. And then you can, right, if I bring back the selection view, can like, right, so in this one, now I disabled depth, right? I can overlay this differently here. And also like remove the boxes, something like that. But right now to like have a completely different kind of visualization will require you to change the application a little bit. But I mean, we're already like offering a lot of like different kinds. It becomes very much down to like, depending on what data you added. But you can like add, like compose arbitrary views here together, like decide what objects they're in. And like a few things have more complex options, like this one can have a different color map. And that sort of thing will soon be also available from code. Right now, these are all like UI interactions. But a lot of people ask us like, hey, I open your application every single time I change the color map, or every single time I put these objects together. Like, what the heck? So, and yeah, like, I mean, actually, it does save the state, but it's like the idea of like you run it new, or you have like a different thing, and you know in the code what you're doing, right? Like normal plotting libraries work like that. You tell them what you want to see. And yeah, sure, it's nice to like do that from the UI, but you want to do that from code. So yeah, we're going to add more and more of that, right? Does it answer the question? I wasn't entirely sure.
Yeah, I think so. And I mean, even adding a little bit more, just from a question in chat now, is there documentation and examples for all of these different types of views that are currently within rerun?
Yes, yeah, absolutely. Actually, I can bring that briefly on screen. So if we go to rerun.io docs. We do have examples here, which goes pretty much through all the examples that we have on our repository. Most of them are Python, sadly, but I think we have 4 or 5 Rust examples by now. So yeah, here like we have like these depth clouds. Oh, they actually look nice.
Oh, okay. So it's like you have some Python way of it has its data and it wants to transfer it over to rerun. And so what you're saying is like there's not as many Rust implementations that would be able to send a certain type of data to rerun just yet.
Frankly, it's mostly just us not adding enough samples yet, right? Like the Rust, arguably the Rust API is more powerful because it's more low level. I mean, the Rust API really comes like down to what I showed here for my little game, right? Like you send these messages, and then they become part of the database. The main thing is, of course, that like if you want to do like a lot of like computer vision in these things, like a lot of these libraries are sort of Python first, right? And yeah, a lot of these samples, what they do is like they grab some Python library and then run algorithms with it, and the output of the algorithm they log with rerun to show them.
Okay.
So, this one, for example, here, if we go there, I haven't looked at that in a while. Right. So this runs this algorithm by Meta, apparently. Oh, all right. Oh, I remember this. Yeah, this is super new, actually. This is a really cool one. So right, they rolled out this new model. You can download it in Python. And that was not a new tab. And right, and then you can see, okay, how well did it actually perform, right? And like try this out on your own pictures and then look at the results in rerun. And our hope is, of course, that also like people developing new algorithms will pick up on rerun and use it for developing. But another thing we found, and that's sort of also the backstory of our founders, is when you want to use these algorithms in real life, you will hit issues, tons of them, right? You use an off-the-shelf algorithm for segmenting something, or I don't know, and they have a gazillion of parameters, and you're trying to build a product, or I don't know, even a toy or anything, and nothing works, right? And you're why did it not work? And that's also again where rerun comes in, right? You log your data with rerun, you have a close look, you tweak your parameters, rinse and repeat, and at someday you're probably going to be successful. With the added benefit, you don't need to write your own visualization tool.
Yeah, exactly. Okay, so that makes a lot of sense. And so for tools that want to have an easy way to say, here's our library, and we don't want to write our own visualizer, so we're just going to write our own bindings to plug into rerun, they can easily have their own visualization like this.
Yeah, exactly, yeah.
Nice, okay.
Since I just scroll over it, I think that's actually another cool example for Gamedev. Right, so we have an example that runs a Python library that does assigned distance fields, right? And yeah, I've been back when I did game engine developments, I love those. And this is this is a little example where we actually show the algorithm, the output, and you can also slice through the actual 3D volume then.
Wow.
So that's kind of nice, right? I mean, you definitely want to use that SDF then as is in your game for all your lighting. But do you really want to write slicing through the data and all the UI interactions? I don't know. I mean, it's also fun.
Yeah.
I mean, this is obviously not for everyone, right? But I mean, it's nice to have a quick way to get started and just try this out, I think.
And I mean, just kind of one extended question here, and then I have a few more in chat. So I know one of eGUI's very big selling features is that it can be added on top of the UI of a game to make it super awesome for debugging. Do you see rerun as something that it could be I'm using Bevy and I want an easy way to visualize stuff that is just data to me right now, and I don't want to run a separate rerun application, and so I'm gonna hit my hotkey so that I bring up rerun and I can start seeing stuff in a different debugging way than eGUI?
Oh my god, that's a great idea. I honestly never thought of it that way, but yeah, sure, why not? I mean, yeah, that could totally work, right? I mean, we would need to. Yeah. This actually plays into a current story we have internally, where the viewer application, we're refactoring a few things and making it more composable, right? Like these timeline views that we saw there. Where did it go? Right, so timeline view we moved here, right? That should really be a separate crate, right?
Okay.
I mean, sure, it can still have dependency to other rerun crates, but it should be easy to fork the viewer and build your own version where you go oh, I don't want this thing here at all, or I want no selection, or I want two selections, right? I mean, at least for a power user who's ready to fork the Rust code, this shouldn't be horribly hard. And yeah, I guess also in the same way, right? I think you should be able to just tell it hey, render this eGUI UI over there. So yeah, it's an interesting idea. It seems a bit unconventional at first, but yeah, why not?
Just a few questions here in chat. So one of them, is the logging added on the fly to the interface, or can I only visualize when the full snapshot is saved on disk?
You can on the fly, right? So maybe I can just bring this up again, right? So if we start this. Right, so this one is now just listening to what's coming in, and if I start my game here, right, so the game is happening live, right? So right now I'm looking at the news data that just came in.
Yeah.
And if I have this side by side, we see that this is a direct representation. And if I kill the game, I was oh, yeah, okay, let's go back.
Okay.
And then I can go hey, save this recording, load the recording. Where was it here? Right, so I can save the recording. Data's a bad name. All right, close my viewer. No, I forgot where I put it. Let's see. Where did I put it? Come, just bring it up. Oh, there. And there it is again, right? So this is kind of nice also to write, you can also do that from code, by the way, right? You can also go in the code and it's like, I actually don't want to like do all this live recording. I just like put the stream to a file, right? Like right now we're streaming to the viewer. We could also stream to a viewer that runs in the browser, thanks to WebGPU. You could also stream to a different computer, or you could stream to a file. So it's fairly flexible in that way. That's also why this like question of like having it on screen like made me stumble at first. But I guess you could also have stream it there, right? You can have your viewer in. I mean, you can already have the viewer in process. So like, yeah, why not?
Yeah, I was kind of just thinking. Well, what had got me thinking about that is I'm like, okay, if I want to use this for tooling and I want to use like some game engine with an editor, then maybe it would be within the editor that I'd have a window that is the rerun window. Or and then I'm thinking, okay, well, what if you're just bootstrapping your own game? You don't have an engine. So for example, like with Valorant, whenever we do flame graphs or anything, this is all recorded data that will then go through afterwards. But what would tooling look like in that case? I'm like, okay, well, yeah, if there's just extra tabs you could bring up, like could be pretty interesting for debugging. But I mean, if it's something that makes sense, then it could be really cool to see. But I like rerun's open source, so someone could just go and try that themselves, right?
Absolutely, right? Yeah, maybe. I mean, since that question also comes up a lot, and I'll just preempt that. Right? So, I mean, we are a little company. We're like 7 people right now, and I mean, we're trying to drive an open core model where like this software and all of this is open source and will stay indefinitely. And the goal really is like the open source project should cover everything that a single person needs for like prototyping. And where we're gonna have later, like we don't have yet, but where we're gonna have later a commercial offering is like everything around sharing on a server, having like cloud services and that sort of thing. But like, yeah, you can just like grab the code and do whatever. Please do. It's like as per usual, it's MIT and Apache. Yeah, MIT and Apache licensed, dual licensed.
Awesome. Yeah, well, that is super cool to see. I definitely hope to see some updates in future months as more versions get released. And so hopefully we can have you back sometime. But Andreas, thank you very much for being here today.
Thank you so much, and yeah, thanks also for all the super interesting questions.
Absolutely, yes. I love going through this kind of stuff, so it's all good. All right, we'll be back in just a minute with Graphite. All right, so we are back for another month of Graphite updates. Kevin, I heard from you that we have quite a lot going on right now, so I will let you take it away.
Okay, yes, we have had a very productive month. So very quickly, if you're just tuning in for the first time and not sure what Graphite is, we are building basically a professional grade graphics editor that's both for vector and raster editing. The entire thing is in Rust except for the front end, which is web-based. And the main goal here is to have everything be node-based. So that way you can take more of a procedural approach, doing some of the cool things you might do in Blender geometry nodes, or in Houdini, or in your compositing software of either Blender or Nuke, or basically taking all of your existing destructive workflow and making it non-destructive. But still putting in a pretty familiar package that artists are already pretty familiar with. So getting straight into it, this past month, I guess it's been a 5-week month this time, so it's been a good time to have a lot done. But we have worked on a number of things, and this is really only just the highlights here. I can just quickly start reading through a few of them, and then I could show off the ones that I can actually demonstrate. So the first one to show off, or the first one just to talk about, is that we have moved the color workflow from gamma to linear. So previously our nodes were basically sending bitmap data through the node pipeline, through the render engine, and they were all working in a gamma pipeline, which basically means that all the color channels had an exponent to them. So now they've been moved to linear, so all of the nodes that interact, if they do need to work in a gamma pipeline, they will transition to gamma and then do their calculation and then go back to linear, rather than the reverse where everything was starting out in gamma, having to go to linear, or a lot of things that required linear had to go to linear, and then back to gamma. And then some of our nodes actually don't care. Some of the calculations work either in gamma or linear, so they actually don't have to do a conversion. before or after this switch from gamma to linear. Okay, the next thing is we have a whole bunch of new adjustment nodes, and some of these are actually really difficult to implement because there's pretty much zero documentation anywhere on the internet about how they work. So I can quickly show off a few of these. Here's a photo that I took nearby my house, and I'm going to now show off the levels node. So this is, we actually did have this node before, but it had some issues, and now it has been fixed. So basically we can increase the shadows. So now the shadows are taking more influence on the image. They're basically moving the left side of the histogram to the right and making the entire image darker because we're compressing the entire image to more of that side of the histogram now. We can also increase the highlights. So now the bright parts are getting brighter, the dark parts are getting darker. And then we can also change the midtones by shifting them to the side. So now we're basically forcing that histogram of pixel brightnesses more to the dark side or to the light side. And then we can also just reset these back to before and kind of just look at how the highlights affect things. So we can keep increasing it more and more this way or more and more this way. You'll notice that some of the performance is still a little bit slow to update. That's because we are now working on GPU execution, and one of the talking points later in that list that I just had open is that we did get some groundwork for the GPU execution, but now this month is what is our plan to get that all finished. So now that also Chrome has released WebGPU as its newest API in Chrome 1.13, we are going to be able to utilize that. So any Chrome-based browser, at least on Windows and Mac, unfortunately it has not come to Linux yet, we'll be able to use WebGPU and basically run compute shaders, which is what powers our node graph. That will be able to run much, much faster than having to do all this image processing on the CPU. And then also we can change the output levels here. So that is basically compressing the output rather than the input and kind of forcing everything to be either brighter or darker, like that. Capping its min brightness or max brightness, essentially. The other node we worked on was exposure. This previously was implemented, but implemented incorrectly, so now we have a correct implementation here. So we can change the exposure by decreasing or increasing the exposure. So it's a nice, easy way to do something that kind of looks like if you were changing the EV value on a camera. Just like this. You can also change the offset. So that basically changes the base level at which it's counting for the offset. Well, kind of hard to explain. I don't know. But it offsets a part of that. And then finally, the gamma correction. This basically allows you to apply your own gamma. So if you, for some reason, had an image that was in linear but needed to be in gamma and it wasn't already converted for you in the pipeline, you could do that. Or you could also do the inverse of 2.2, which I believe is like 0.8 or something. Like this. I guess I could check by saying 1 divided by 2.2. That would be, actually 0.45. So 0.45 would be looking like that. So I could also do another one here, duplicate the exposure node, and now I could do 2.2 and basically reverse it back to normal. So here it was before, here it is after. And of course, you can actually change the exposure because that's the whole point of the exposure node. Okay. The next one is brightness and contrast. So this is the one which has no documentation online at all, and I had to do some crazy figuring out of things. But yeah, you can actually change the brightness. This is a little different from the exposure that I just showed in the previous node. And then also contrast, so I can basically crush this histogram. And the way this ultimately works is it is generating basically a levels node. It's generating a curves node. Or it's generating a curves image filter. And we actually don't have a curves node yet, but we will soon. But essentially it's generating a curves node which has 4 points that define a curve according to the contrast value and also according to the brightness value. And these sliders essentially shift around that. Then also there's legacy mode, and this does not use curves. It instead just kind of applies sort of a constant offset in division. So feel free to take a look at the source code to see how that works, which is possibly the only open source code that explains how these work. Maybe GIMP would have been available. I maybe should have checked that, but yeah, at least that was all I could find. I had to do some math and figuring things out here. The next one is the channel mixer. Basically what you can do is you can say, I want to target the red channel, and so the red channel naturally will have 100% by default. Also the green channel will have green of 100% by default, and the blue will have blue 100% by default. But basically you can get the other channels to have influence even in this channel. So the blue channel now has more influence from the red channel and less from the green channel, for example. So you can, I want to make my scene less, or let's see, more green, but in the blue channel. Or maybe I want to have the green channel have less green in general. So we'll reduce the green. And then you can also tell it to be monochrome, in which case instead of affecting all the 3 channels, you're basically just affecting the output gray color based upon the red, green, and blue. So of course if I reduce the green, then we have almost nothing left in the image because the image is mostly green, except for the flowers. And then finally we have a constant value which basically applies an offset, and that also existed in the red, green, blue version. So yeah, that's also taking in kind of the standard adjustments that you get from most image editing software. Oops, I didn't mean to delete that. And then we finally have the selective color. So this is the last of the ones that we added this month, which gets us relatively near completion of most of these standard adjustments that exist in most image editing programs. So we have the reds. We're targeting the reds, and there's actually not many reds in this image, so not much is happening here. But we can go over to, let's say, the yellows, which might affect the poppies a bit more. So we can increase or decrease the cyan, but I guess cyan doesn't really have much effect in this case. But we can increase and decrease the, yeah, there you can see. The magenta is affecting the poppies a lot. And the yellow, decreasing and increasing, of course, the poppies there. And then, of course, we can go between absolute and relative mode, which basically you can just try out which one looks better. And of course we can go to the greens, and this is going to have a much bigger effect. And I'll just play with it real quick before moving on. So yeah, absolute and relative, just play with one, whichever one looks better. So yeah, those are the new adjustment nodes that have been added. And let's see, let's move on to the next one. So now, the very exciting thing is we finally have a brush tool, which is possibly kind of an important feature in image editing software. So you can go ahead and, say, pick a color, like, I don't know, let's draw a butterfly in here, to the best that I could attempt to draw a butterfly. So I'll go with a kind of a small brush size, and let's go ahead and add a little bit of a butterfly shape, I guess. So fill this in with some of this yellow color, some of this pinkish color. And then I can draw with additional parts on the next layer with additional colors to kind of fill it in here. This is not looking like a very nice butterfly, unfortunately. But I can go with a new layer. It's limited to only having one type of color per layer, but let's go with, actually I'm gonna change the color of this. So here I can show you how you can change the color of the entire layer, and that's why at the moment it's limited to one color per layer that you've drawn on. It's just because we only have one color choice here. Let's make it a blue butterfly, I guess. And then let's make a new layer and draw what else looks like a butterfly. I don't know, maybe like a brownish color for the body portion. Definitely use reference if you're making a drawing that actually should look good. Then I can also make another one which is smaller again, let's say 10 pixels, and let's also increase the hardness to like 90%. So now we can see, I don't know, they totally have antenna, right? And maybe we can give it a little bit of a border to its body as well, or to its wings. And then we can draw some little patterns on a third with the different colors. So let's pick, well, this original color was fine for this one. And basically I'm going to go back to the primary color, which is this one. And I'm going to go with an even smaller brush size, and I'm going to make it 100% hardness, but I'm going to say 50% flow. So the flow basically affects how opaque it is. And I can draw some little things that definitely is a real pattern on real butterflies for sure, without any question. Okay, there we have our terrible butterfly, and group those all together. And now I can just scale this group down and put it on one of the flowers, because that is beautiful, totally a masterpiece. So yeah, and that was basically a quick demo of the brush tool. One thing that's kind of cool though is if I wanted to change the size of those antennae, for example, so I drew the antenna here and also the outline of the body, all I have to do is decrease the diameter by typing 5 in here, and it actually re-renders the brush stroke. Or I could type, I don't know, 50 if I wanted to go crazy, and it will re-render all of those drawings that you did, because all we're doing is we're recording your mouse movement and re-rendering it each frame. I can also decrease, the flow if I wanted it to appear less visible, more transparent, and also change the hardness, make it softer or much harder. So yeah, that is what you can do with the brush tool. The performance does suffer a little bit, but that will improve once we have the GPU execution this month. So now the tools have color choices. So as I briefly showed here, any of the tools let you choose either between the primary, so this is your primary working color. This other one is your secondary working color. So these are the same across all tools. I could switch to a different tool and switch to a different tool, and they're always going to stay the same. And by default, some of the tools will either use the primary or the secondary. So you can see that the primary is used, and that's why it looks green. But I could also go to a custom one, and now it's black, for example, and then I can change it here. And I could even remove it entirely if I wanted to have no color. And those will stay with the tool. So I switched to a different tool, now we have different primary and secondary, and then I switch back and it will stay with the tool. So at the moment we have it set to none on the text tool. I can go to the rectangle tool, and we have, it'll look like this because we have the primary used for the border or the stroke, and the secondary, which is the blue color, used for the fill. And then of course, once you've drawn it, you can go, like always, and make adjustments here. In the properties panel once the shape has already been drawn. Yeah, so that is the ability to make changes quickly to your tools. So you might say, I want to use the secondary color instead of the primary color. So I'm going to draw this shape, and then I'm going to go back to the primary color and draw a new shape that is green. And then I want to do a third layer and just quickly change it to some other color, like this one, and then draw that one as well. Okay, next one is that, gotta rush through these. The next one is that text layers have been converted to the node system. So previously, we had a bunch of different types of layers. We had vector layers, we had image layers, we had stable diffusion generation layers, we had, and then finally also the text layers, and this was the last one. So we've drawn something, and we have no color, because remember I turned off the color, so let's give us a color real quick to see it. So now, this is no longer its own separate layer type. It is now part of the node system, which means that all the layers that exist, they just say layer, they have a little layer icon, and they all have their own node graph. So we can see that, the butterfly, for example, had a brush node, and that feeds into the output. This text tool now has a text node, and you can always go modify the text here. So you can see now we have the text, of course. And now we also, of course, it feeds in through the transform and the fill. So that applies the positioning as well as the fill color, which we have here, and also the stroke, which we have here. So the stroke could actually give it a bit of a outline if you wanted. So that now is all standardized in the node system. So we only have layers, these node-based layers, and our next step is removing these layers and having a single node graph for the entire document, and that hopefully will be coming in the next month or two. Okay, next is that points of shapes can be nudged and transformed. So if I'm going to draw something, let's say I wanted to draw a pentagon here, and I wanted to resize these three. So now I can actually just select them and hit S, just like Blender style shortcuts. You can hit S and then scale things around. So I can say I want to scale it to 0.1, so that's 10% of its original size. And then I can hit R and do 180 and rotate them like that. And oh yeah, I can also do G and then X and then constrain it to the X-axis. Yeah, and you can also nudge them around. So you can select these ones and then move them around like this. So this is something that I wish other vector editing programs, like I frequently use Adobe Illustrator, and I really wish that it had the ability to more easily just rotate and move points around like this. Yeah, next item on the list. Getting through these quickly now. We have fixed some of the major issues with images. So in one case, any file that embedded an image basically stored the red, green, and blue channels as ASCII with like 10 points of precision. So you'd have 10 ASCII characters representing, or like 12 ASCII characters representing a floating point number for both the red, green, and the blue, and the alpha channel. And it basically made any document you saved like 50 to 100 megabytes, which was crazy, even though it only had like a few kilobyte image inside. So that is now saved as base 64, so much more efficient. And additionally, we have fixed some other crashes related to the fact that we were running out of WASM memory because we were never evicting any of those images every time they changed. Finally, so we've done some groundwork for GPU execution. So now the next step is basically integrating it with WebGPU, and that's what we're working on right now. And also the groundwork for the node-based layer system that is now going to be, basically we have added a layer type which exists, and it's not useful at the moment, but that's moving towards having this be the mockup. So implementing this mockup, this basically is a mockup I created for how the node system will work very soon. But basically these are layers here. So each of these are layers, and we have now begun working on how these layers are represented. And a major task for me coming up in the next few days is to edit the CSS to basically represent all of what you're seeing here with an upgrade to the node system. And with that said, I believe we are done. Yes, we are done. So thank you for your time again, watching every month. And if you'd like to get involved, please check out our Discord, also our website, and play around with the editor. The editor is still deploying a version that's about a month old. So if you do want to try out these newest changes, go to the master branch, which is deployed at dev.graphite.rs. And we'll try and get that the official editor stable release deployed relatively soon. But yeah, come join the Discord and say hi, and maybe pick up an issue or two. Thanks for listening.
Awesome. So we have a few questions here in chat. Thanks for showing off everything. It's super cool to kind of see how the brush is evolving. One question about the brush. When using a brush, you showed that changing the hardness or flow after having drawn on a layer. Does this mean that the brush strokes are stored in some representation internally and rasterized from that?
Exactly, yes. They are stored as points, and they get rasterized on the fly.
And now, just kind of like transitioning this from like several months back, where we were taking a look at like how brushes were then drawn on top. Has there been any like progress in like that brush system of how strokes and everything are kind of combined, or?
I'm not sure I understand the question, because we have not had brushes until now. We did have the freehand tool, which is this tool here. So I can draw just a shape, but these are all vector shapes. So, I can just move these points around. I can turn it into any other shape. It's basically, I can even like double click on a point and give it curves. So this is basically a quick way to draw a vector shape, whereas this other one is actually raster based.
Well, so I think what I'm thinking, maybe it's just my terminology here is a bit missing, but like when you're showing off the work that you're doing for your masters, like how there was some stuff there, and I think I interpreted that as just being for brushes.
Yes.
But were those?
That was all a separate code base, very much a prototype that would take a while to implement in
Okay.
Rust.
Yeah, okay, that's fair. I think for myself, definitely cool to see like that. I mean, even now you could draw a brush, and then presumably once that version is available sometime off in the future, just you have all the data there already, and then you can just add the new brushes to that.
Yeah, it's sort of, we would have to make a whole bunch of nodes that kind of work together. It's sort of a family of nodes that all build out that system of essentially creating a procedurally defined brush, which reacts to different things, different parameters, such as your brush pressure, your pen pressure if you're using a stylus, and the tilt angle and things, where it would sort of do a a procedural material definition that gets wrapped around your brush movement. That was the focus of my thesis, and that will be something we implement probably over the next 6 months or a year, unless someone really likes that idea and wants to join the project and do that for us right now. That would be, I don't think it's really blocked in anything, so that could work.
Awesome. Another question here: how often do you push alpha releases to your website?
It's gotten a little less frequent lately because I guess we want to stop breaking people's files. So we'd rather they just use an old version of the editor for a longer period of time rather than having their files break every day. So it's been more like every month or so lately, but we typically try and do it like every 2 weeks. That would be the goal. Yeah.
Mm-hmm. Yeah, no, I think we have the same thing with Valorant, where it's been like, we stopped. We went to like a weekly release, and eventually it'd be nice as a game to have like every just stable release that comes out, and then content is added in between them. But definitely.
One thing we really need to do relatively soon is come up with a strategy for a file format, a proper file format, not just using Saturday to write out some JSON text of our internal representation of our structs, but actually a proper file format that has backward compatibility. Because every single time we ever make a change to our internal document format, or the node graph format now, it does basically break anyone's files that were using those structs.
Yeah, JSON, certainly JSON goes a long way before you have to consider, potentially consider these issues. I guess, like versioning is a big thing.
Yeah, but it has allowed us to move quickly, not having to support people's files.
Exactly.
But of course, that unfortunately means we don't really get to let people continue to publish their files, because if someone even bothered to publish their files, or if we bothered to publish a demo file, like this beautiful artwork here that I worked on a few weeks ago, it's already out of date. You can't open it anymore.
Yeah.
It would be nice to be able to publish these so people could play around with them. But,
exactly, yeah.
Yeah, but they are short-lived.
Just one more comment here. Rob Twain mentions that they love the UX touch of dropping the node between two nodes, and it gets inserted between them. So nice little.
That is super important.
Yes, gotta keep it feeling good. Yeah, absolutely. All right, well, Keegan, thank you so much for the updates.
I was going to say quickly, we also want to be able to have drag one of the nodes that already exist and shake it with your mouse, and it'll break free of its connection, which is basically the opposite of that operation.
Yeah,
that is something we want to add, but it just takes a little bit of effort, because you gotta have a little bit of an algorithm in JavaScript that figures out, are you shaking? And if you're shaking, are you really shaking, or are you just accidentally moving your mouse sort of back and forth a little bit? We don't want to have too many false positives or false negatives. So,
exactly.
If someone wants to contribute an algorithm, I did look this up and could not find any kind of pre-existing algorithms for shake detection of your mouse, because it's sort of a very specific thing.
Yeah. Well, I mean, this would be a really great Rust trait for anything, I think, is just have the ability to do gestures and stuff like that.
Yeah, that's true. Yeah, it might be able to be Rust. It probably would be better being JavaScript, just because it's such a self-contained thing, and it's very close to the front end. It's dealing directly with user input, and pretty much the user input is the entry point of the JavaScript project, and everything else then gets redirected to Rust as basically as events.
I mean, you can always ship a Rust project in as a JavaScript package with Wasmer. I think that's a new thing that they have. It is a little bit extra file size, I suppose, but hey, if someone wants to make it, it sounds like it'll get some stars.
Yeah.
Okay. I guess another suggestion here: click, drag, press another key or mouse button to disconnect the node. So, I guess in that case, it's more like what shortcuts could you use to make that feel good as well?
Instead of the shaking. That's true. We definitely could add a shortcut, either to you tap it and it immediately disconnects if you're already dragging, or alternatively hold down the key to kind of, as soon as you start dragging, it'll disconnect it.
Yeah. Well, I mean, even just thinking a little bit more though, if I wanted to use graphite on an iPad with a pen, then me being able to shake the pen to do something there, or interact with this, so I have to use fewer shortcuts.
That would be cool. Yeah.
Yeah.
We definitely plan to eventually support iPad, but it's the kind of thing where we definitely are keyboard focused at the moment, and we will have to work later on once we have enough features and sort of figure out how we can take a strategy to changing what we have at the moment and tweaking it to work better without keyboard.
All right. Yeah. Well, good stuff. Thank you so much for presenting this month, and excited to hear about the updates in the future.
Yeah. Thanks.
Wait, I forgot to mention that's the end of this month's meetup. I'm supposed to go to the go and do like a little wrap up here. I forgot about that part. Okay, so as always, again, as I mentioned, contribute to the newsletter if you got some cool stuff going on. A little item. I'm going to try starting to put up YouTube videos of the cut content from the meetups, and so hopefully you can go back and watch some of the stuff in like a more condensed form, I suppose. And other than that, yeah, we will catch everybody next month.